Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, on to the next lesson, 3.2.3. This lesson is one where we kind of embed solving equations with our problem solving, which you saw quite a bit last year when we were doing the 5D process, probably actually more than what we're doing today. Still, it's the whole reason why we learn how to do algebra is because we can model our problems with an equation. We can use our algebraic reasoning to solve the equations and thus solve the problem. So in the last two lessons, you have practiced solving equations. In this lesson, you will apply your equation solving skills to the patterns you found at the beginning of this chapter. As you solve these problems, keep the following questions in mind. How can you simplify? Is there more than one way to solve? Can you get x alone? And how can you check your solution? Okay, so you may recall from lesson 3.13, the big C problem. And as a part of that problem, we noticed to go from figure 1 to figure 2 and then figure 2 to figure 3 was a constant growth rate where it was increasing by 6 every single time. And as we worked backwards, if we took away 6 from figure 1, then figure 0 would have started off with these 3. And so the rule that applied to this situation was y is equal to 6x plus 3, where x represents the figure number and y represents how many tiles would be in each figure. So if we just take figure 2, we've got 6, 12, 13, 14, 15 tiles in there. And figure 2 would be, your x would be 2, so 6 times 2 is 12, plus 3 is 15. So y equals 15 is the number of tiles. Excuse me. So Penelope wanted to know how many tiles will be in figure 50. How can you determine this? Write out in words, please, what you would need to do with your rule to answer her question. Then answer the question. How many tiles would be in figure 50? Please go ahead and take a moment to think about this rule here and how you would answer that question. What is the work that you need to do? Okay, so just a brief sentence or two explaining how you would figure this out and then declare the answer properly. I'll go ahead and pause, you go ahead and pause, and then when I come back, we'll reveal the answer. Okay, so words, what is it that is happening here? First thing you would do is you would multiply the 50 times the 6, right? Because that's the rule. We take your whatever your figure number is, multiply times 6, and then you add 3. So if we actually show this process, we would plug in the 50 where the x goes and then work through the order of operations to simplify this expression. 6 times 50 is 300, and 300 plus 3 is 303. So we would then declare the answer that there would be 303 tiles in figure 50, or figure 50 will have 303 tiles. Okay, so Lou wants to reverse the process. He says he has a big C figure made up of 45 tiles, and he wants to know which figure number this pattern would work for. Okay, I think I said, let me just read that again. He says he has a big C's figure made up of 45 tiles and wants to know which figure number this pattern is. Okay, so in the rule y equals 6x plus 3, which variable must equal 45? Right? This is the number of tiles, correct? And so we said here that y would represent the number of tiles in the figure. So that means that we would plug in the 45 for the y variable, correct? Yeah, the y must be 45. So then it says for part B, write an equation you could use to solve Lou's problem. So that equation is going to look like this. Go ahead, pause, and solve for x, and then declare your answer, which figure number would have 45 tiles in it. All right, so what's the first step that we would do when solving this problem? You would want to get the x's all by themselves, correct? So we would take away this 3, that forms a 0 pair, which means we would also subtract 3 from the left side because we are removing balanced sets, which would give you 42. So now we say 6x is equal to 42. And think about your times tables. What would you multiply times 6 to give you 42? Well, if we take and we divide each side by 6, 42 divided by 6 is 7. What that means is, for Lou's situation, it must be figure 7 that has the 45 tiles. So remember, checking is an important element of this. So how can you check your answer to be sure? Well, you should always start with the original equation. The 45 is equal to 6x plus 3, but you want to substitute your answer for x into the expression, or into the equation, I should say, the expression on the right, but the equation, and then go ahead and simplify. What is 6 times 7? It's 42, and 42 plus 3 is 45. So we know that we've got the correct answer. It must be figure 7 that yields 45 tiles for this particular configuration of tiles. Norm says he has Big C's pattern made up of 84 tiles. He wants to know which figure number this pattern is. Write and solve an equation as you did in problem 90. Does your solution make sense? Why or why not? Okay, so in this situation, we've got 84 tiles, right? So we're going to plug the 84 in. So instead of y equals 6x plus 3, we'll say 84 equals 6x plus 3. Go ahead and solve this equation, and then write out a little statement. Does this make sense? Why or why not? Do you like the answer, or is the answer not okay? Okay, go ahead and pause. I'll pause as well, and decide what you think. All right, so did you get your answer? Now, the first step, we want to get our x's by themselves, right? So we want to clear out that 3. So if we take away the 3 from the right side, we're going to remove balanced sets, and we'll take away 3 from the left side. So now our new equation says 81 is equal to 6x, or 6x equals 81. Now, what do you multiply times 6 to give you 81? There is, I mean, 6 times 10 is 60. 6 times 11 is 66, then 72, then 88. Where does 81 fall? No, not 88. What is it, 84? I'm even getting confused. 6 doesn't go into 81 evenly. When you divide it, you end up with 13 and a half. So I guess it comes down, does this make sense to you? If you think it should be okay to have figure numbers that are rational numbers, then I guess it would be okay. But up until now, we have not had anything other than whole numbers for our figure numbers. So the answer would be figure number 13 and a half, or 13.5. And since we've only been working with whole numbers, I would say that this answer does not make sense. Okay? That's just me, though. If you say no, I'm okay with us having decimal or fractional figure numbers, then okay, then I guess it would make sense to you. But we haven't been working with those, so I'm just going to say let's not go in that direction. All right, so here we are. I would like for you to copy down these equations, and I would like for you to show your work and solve each one of these equations, okay? You've got fractions and decimal numbers embedded in. This is going to be a struggle. I can't tell you how many students I have taught over the years who are excellent at solving equations, but the moment you put fractions or decimals into the equation, people freak out, okay? It's not that bad, especially if you're allowed to use your calculator. And I'm encouraging you, go ahead and use your calculator to help you with these processes. If you remember, I think I might have briefly touched upon fraction busters last year and decimal busters. If you remember the strategy, feel free to use it. But for many of you, you may not remember, and you're just going to have to deal with working with fractions and working with decimal numbers, which is something we have to do in real life. You've got to master this. So go ahead and take some time, copy these equations down, work through the process, let the calculator be your aid, and then declare your answers. You do want to check. And the check in these situations is often harder than actually solving the equations. Sometimes the checks are super easy. You can almost do them mentally. Sometimes the check is more work than actually solving the equation, but it's so important for you to be confident that you have the correct answer, especially if you want to get good grades on your assessments. So practice it, okay? Take your time. There's no rush. There's no prize for showing as little work as possible and getting it done quickly. The prize is knowing you've done everything properly and getting the correct answer. Okay, so go ahead and pause and work through this. And when you're ready, unpause, and I'll reveal the process and the answers to each one of these. All right, let's see how you did. First off, we copy the problem down. Now, my first thought is collect your x's on one side of the equation. And since you got a half of an x here and a full x here, I would rather take away half of an x from each side than take away a complete x from each side and end up with negative number of x's on the left. So let's take away 1/2 of an x from each side, and that leaves you with the -2 on the left, and then only a half of an x minus 4. So now that we've got our x's on the right, let's clear out the -4 by adding 4 to each side. And -2 plus 4 is equal to 2. And now just thinking about a little bit of logic, what do you multiply times 1/2 to give you 2 for an answer? Sure, you could say 2 divided by 1/2 is 4, but in this situation like this, maybe you just kind of use a little mental math. Half of 4 is 2, so x has to be 4. Now, if we check that, what's half of 4? Half of 4 is 2. This becomes 2 minus 2, which is 0. And x minus 4 would become 4 minus 4, which is also equal to 0. So that checks out, which means for A, the correct answer is x equals 4. For B, we copy the problem down. And now same idea is I want to collect my x's on one side. If I add a quarter of an x to both sides, it'll cancel out the x's on the left side, leaving you with only the 8. And now you'll have 75 hundredths of an x plus 2 on the right. Now we'll want to cancel out the 2 so we can get the x's by themselves. So we subtract away 2 from each side, and that gives me 6 is equal to 0.75x. And now this is where using your calculator comes in handy. You divide each side by 75 hundredths, and 6 divided by 0.75 gives you 8, which means x in this problem has to be equal to 8. So let's go ahead and check that. This is, remember, a quarter, and that's the same as 1/2. So a quarter of 8 would be 2, so that becomes 8 minus 2. And a half of 8 would be 4. 8 minus 2 is 6. 4 plus 2 is 6. 6 is equal to 6, which means we feel confident that our answer for problem B is x equals 8. For problem C, copying the problem down, looks like we're going to have to do some combining of like terms. So I'm going to add this negative, or actually it's a subtraction, right? The x minus the 0.5x. So that leaves you with half of an x here, right? Because you got a full one, take away half of one, and that 2 doesn't get combined with any 1, so it stays there. And here, the half of an x stays there, but you add the 1 and the 1 to make 2. So do you notice that these two expressions are exactly the same? That's an indication that any number for x would work. Whatever number you plug in here, you have to plug in the same number there. So regardless of what number you plug in, they're always going to be equal to each other. So this is one we would not be able to check. If you did want to check it, just to know for absolutely certain that it wasn't supposed to be no solution, I endorse that. I think that's a great idea. If you're having trouble remembering whether it's all numbers or no solution is the answer to a situation like this, then plug in a number. If you plug in a number and it works, then you know it can't be no solution, right? So if I plugged in the number 0 here and here, you'd end up with 2. And then you plug in the number 0 here and you get 1 plus 1, that's also equal to 2. So is 2 equal to 2? Yes, it is. That means 0 is a solution. So the answer couldn't be no solution. Let that sink in a little bit. I hope that makes sense to you. Otherwise, it's kind of pointless. Any number you plug in will work. So checking it seems kind of it's not really going to help you too much like it did over here. And then the last problem. 7x minus 1500 is equal to 2x plus 6/10. So I would take away 2x's from each side. So you've got 5x's minus 1500. Then I take away the 1500. No, I guess I have to add it, right? Because it's minus 1500. So when you add 1500, that forms a zero pair. So this becomes 7500. And then you divide by 5. And this is another one where the calculator comes in handy. You can take 7500, 0.75 divided by 5, and you get 1500. So 1500 should be the solution. So let's check that to see if it works. You take 7 times 1500, and that's 1.05 minus 1500. And then here you got 2 times 1500, which is 3/10. You add 3/10 to 6/10, you get 9/10. You take away 1500 from 1 and 500, and you get 9/10. Those two are equal, which means we feel confident about our answer, and we declare our answer x is equal to 1500. Okay? If you've got this mastered, you are doing great. If you can solve any of these equations with no trouble at all, with help of a calculator is totally fine, then you are right on target. Pretty much the only thing left to do is throw in some distributive property into these types of problems, and that will be about as complex as these get. Okay, so if it's still a struggle for you, don't worry. Homework is going to have these types of problems twice a week for the entire school year. You will get plenty of practice with it. The more times you do it, the better you'll get. The more mistakes you make and you correct your mistakes, the more you'll be tuned into what to do and what not to do when solving these types of equations. Okay, so just keep at it. I promise you it gets easier. All right, last problem. Can an equation be solved using a graph? Consider this as you answer the questions below. First off, copy this equation down and solve it, and then check your solution. Let's just do that first. Okay. Unpause and unpause when you think you've got the correct solution for x. All right, so you would have copied down the equation, then you would have taken away 1 from each side, so that becomes a 4. And then we divide 4 by 1.6, and once again, let's use the calculator. 4 divided by 1.6 gives you an answer of 2.5. So you should have said that x was equal to 2.5. Now, if that is correct, then we can plug in the 2.5 for x and then use the order of operations on the right-hand side, 1.6 times 2.5. Well, we just did it with the calculator, but let's show it again. 1.6 times 2.5 is 4. And then 4 plus 1 gives us 5. So we feel confident that the answer is correct. So we're going to declare our answer is x is equal to 2.5. Now, complete a table for the rule. All right, let's see how you did. First off, I'm just doing the math right here, the mental math. We know 0 times anything is equal to 0, so one of the points on our graph has to be 0, 1. When x is 0, y is 1. When x is 1, 1.6 times 1 is 1.6. Add that to 1 and you get 2.6. When x is equal to 2, you're going to double 1.6 to make 3.2, plus 1 is 4.2, and so on, and so forth, and so on. Now, when I made the graph, I counted by ones on both my x and my y axis, and I chose to plot this point and plot this point. Those should be 2 easy points to find on your graph. Once you plot those 2 points, then you connect those 2 points with a line, and all of these other points should fall right on that line. Okay, so let me give you the graph as I see it. I plotted the 5, 9 here and the 0, 1 here, and then I connected all of those, or I connected those 2 points, and then each one of those falls right into place. You just basically, where x is equal to 2, plug that in. Does that look like 4.2? Yeah, that's about 4.2. Where x is equal to 3, does that look like it's about 5.8? Yeah, it does look like 5.8. So I feel very comfortable that that graph is perfect, okay? So now to answer the question, where y is equal to 5, this point right there on our line would be where y is equal to 5. So let's go ahead and go straight down. What is x equal at this point? So this is this point right here is where y is equal to 5. What is x equal to? Well, x right there is halfway between 2 and 3, so that would be 2.5. So isn't that the solution that we got up here? It is. So, did you get the same result? The answer is yes, we got the same result. Now, one of the problems with using your graph to solve these types of equations is, how do I know that isn't 2.48 or 2.45? It's really hard to tell with my scaling. And I don't know that I want to create a graph that's super huge to where you would be scaling it by like counting by tenths or counting by quarters so that you get a more accurate reading. So graphs are nice for making predictions and estimates, but they're not necessarily going to give you that perfect answer. Tables are nice for identifying a pattern. One way that you're going to get perfectly exact answers is by setting up the equations and solving the equation. And that's what we did here. And here we know the exact answer is 2.5 because we solved the equation and we used our calculator and we checked our solution. Whereas here, it just looks like it's pretty close to 2.5. Now, since we knew the answer was supposed to be 2.5, we can look at that and say, oh yeah, that's got to be 2.5. But if you were relying on the graph to get your answer and you hadn't solved the equation, it might be a little bit more challenging. So it's going to be very critically important that as we progress, that you are proficient with setting up tables, with graphing, and with solving the equation based off of a rule. Okay, so that does it for today's lesson. Did we get that in? Okay, yeah, less than 25 minutes. Not too bad as far as the video time goes, but I'm sure you spent much more time than that solving those equations. So good job, stick with it, get to your homework, show your work as much as you can, and make sure you check those solutions every time you solve an equation. Okay, take care, bye.
Hey, feeling good, like I should.